Hey everybody, good morning. Thank you for joining us. My name is Anthony Tosi. I work for Wales Darby, and today's topic will be low temperature, high efficiency. It's a topic I think worthy of an hour's worth of a mishmash of slides. You see my co-partner here with Wales Darby as well. We're in the Contractor Services department, Mr. Rick Costa. He'll be behind the scenes.
Good morning.
Good morning to you as well. Early start for all. Thank you for being here again, and hopefully, you get something out of today's presentation. It's a regurgitation of something I did back in April, but there'll be a second part to it, and it's more of what the new technology is going to be asking of you and us as a rep, right? So we're here to to help assist, influence a lot of the above, to make sure moving the ball with equipment, right? We have a lot of new stuff coming out. Technology is not going to stop, and we really need to get comfortable with this title on the screen, low temperature, high efficiency. And you'll see as some of the slides, I'm really drawing at you guys to think about what you do with the comfort level that you have, and now you're going to have to shift a little bit. You're really going to have to see that lower water temperature isn't a bad thing. It's going to be a must to play nice with this new modern heating, right? And I'm talking about air to water, and we'll see as this progresses. All right, so this first slide, just to say, this is Wales Darby. That's obviously our logo, today's date, and then the picture I put up there, that was a photo shoot, and a lot of legal actions happening just in that one photo, as I recall, because I'm the guy driving the van that day, and that's our mobile learning center. For as long as I've been with Wales Darby, close to 25 years, it's always been about educating and making sure what the next greatest thing is we're bringing to the market and now our territory. And where we've done things before as just mock-up trainings, we've built training rooms, we've built this mobile learning center, which is our vehicle. It's all decked out. I've always asked the question, knowing this, how many people here today, as far as a webinar, is like, where are you guys coming from? If not to take advantage of, we have two locations. We have New York and New Jersey, and that's what this next slide is here. Just introduce ourselves again. There's a couple QR codes there. If you want to take a picture, that will be our contact information for both Rick and myself. But the picture in the center, that was one of the training rooms we built, and that's in my Islandia, New York location, which is in Hauppauge, exit 57 on the Long Island Parkway, or parking lot, I should call it. It's really called an expressway, but it's just the opposite at times. Kind of flanking around the picture are some of the manufacturers, not all that we represent. We also have handouts today. If I go back a slide, I don't know if you guys saw this, it says check out, and there's a blue arrow there, and that's in your window. That's in your go-to webinar. You have the ability to ask a question, interact with chat, and also this handouts, and I believe there's 5. And you'll see during the course of the presentation, this will repeat this little logo saying go-to webinar, because if you're looking for the information that's right now being talked about, let's say, you can have that as well. So I put 5 handouts, one of them being Wales Darby's line sheet and our contact information. We do a little things differently here, and we do use QR codes quite a bit, and we find it to be very kind of, let's call it modern, no more paper, the ease of someone taking a picture with their cell phone, and this is what you can do right now. If you're not on your cell phone, you can use your cell phone's camera, you can take a picture of those QR codes, and now you'll have all our information. What I ask is just simply to have an engagement, is text me, first name, last name, who you work for, and where we met, and you can just reference today's webinar, and then that will go into my phone. You're much better calling me and coming up as a name or a person as opposed to 10 digits. So we all get busy and sometimes get lost in the sauce, so to speak, but I've been known to pick up the phone even during training classes, during the next break, or a simple text message, hey, everything all right, how can I help you? But the truth is, sometimes just seeing 10 digits, I think someone's selling me a warranty for a car I haven't owned in 8 years. So let's begin. Here's the titling, right? The title slide, part 1 of lowering water temperature. And I can't say enough about, wow, this really kind of changed the way I think about what I've been doing for the last 20 some odd years. First thing and foremost, you're going to see a lot of things on this slide here. First line item is heat loss. We have to start understanding envelope over equipment. The envelope of the building has to be the focus for what we're doing. Now, whether you're asking someone else to do it, or you're engaging and learning, or you've been doing it for a while, there is no other better step off in the right direction than doing a heat loss. Room by room, envelope of the building, zone by zone, however you want to approach it. That tells you exactly what the equipment then needs to be sized as. So you'll see later the bigger isn't always better approach, right? So let me just go through some things here. As what we do today with maybe modern boilers, a modulating, condensing, wall-mounted boiler, right? We're asked to do sizing correctly, primary, secondary piping, closely spaced heaves, buffer tanks, perhaps, using proper venting, right? Polypropylene for all of our mandates or codes, or even liability, personal liability as a small business. Understand the difference between materials with combustion, products of combustion, right? Setting up the boiler with a combustion analyzer. I can't tell you enough the importance of, regardless of the type fuel, you need to see the real need to do a combustion analyzer, even on a maintenance call, on a service call. The liability is he who touched it last, right? And there's a lot of things down the road without setting it up properly will short life equipment, okay? Flow through magnets, ECM circulator, like all the modern stuff that's changing on everyday items for us, right? Flushing and treating. So these are things that maybe, hey, I don't do that whole list, and yeah, I heard I should, but there are reasons for each one of those line items as to what it means for this really costly, piece of equipment called a modulating condensing boiler. So I say down here, we've been busy doing, but forgot the most important thing, and that is the next step, which we need to understand, lowering water temperatures. It's really important to see that. So just to kind of get into the first half, right? This was part one, and you'll see there's a handout here. The pony we ride is NTI with our condensing, natural gas or liquid petroleum LP gas condensing boilers. So I kind of did a spin of like, hey, how do I describe what is this? Why this boiler versus that boiler? And there is a lot of things that are built or engineered that we're paying for that I don't know if we're 100% seeing the value to take advantage of, right? So my little spin on is a high BTUs, low volume, high efficiency rated, right? We install them, but we don't actually achieve some of these ratings. It is a flow sensitive, right? So we have certain things like a dedicated boiler and modulating heat engine, right? So, to spin what, it's a boiler. Well, not every boiler is built the same, so let's give it a different name. Let's call it a modulating heat engine. The pre-mixing gas burner, right? The computer, so to speak, the software in programming is driving the blower to draw the gas based off of its demand, right? We have to see delta T, we'll see flow, we'll see certain aspects of what we need to achieve. It could be a priority zone and it goes to a high fire. Who knows? It could be modulating for radiant. We have a low fire, a high fire. So these are all the things that we want to achieve if we're installing a piece of equipment like that. It's a costly item. And I've seen more bad over good in a lot of installs. And I'm not saying mechanically wise, but the longevity, the shortfallings of igniters or electrodes or blowers even. There's a lot of premature failures because of maybe what we're not just that little bit more, and really change the dynamic of what we do on our installs. The picture up there, right? It shows here, the heat exchanger. It really is engineered and designed to work in that corrosive environment of what we want to achieve. Condensation, right? We want this thing to condense. When we're condensing, we're in that higher state of efficiencies with good practice, okay? So the materials are costly, and you know, I've seen more times than not, man, with lack of maintenance or proper venting, right, cross contamination, it really short lives this, you know, pretty cool item. You know, it's this marvel of engineering. So neat stuff to maybe next level stuff for us. Take a little deeper dive into maybe the installation manual, reading what it is and how to properly set up a combustion analyzer, realizing why is it that I do have a run of short life equipment. Take a look at your venting. I can't say enough, venting is a lost trade. And I've been on many jobs and taking lots of pictures of just bad applications, you know, terminations that people want because of the aesthetics and how now it really affects a short period of time, pretty expensive equipment. And then they kind of look back at the manufacturers, there's a problem. And I can go to a job site and I have my kid gloves on as I try to, but more times it's an application approach, okay? So the heat exchanger is key, and what we wanna do is take advantage of lowering water temperature. Now, this is just a quick illustration, and there's, you know, one of our boilers, this is our fire tube, and you can see in this illustration the red kind of ovals going across on top and bottom to blue, and there's a break in the middle. So this is what we had a cutaway of a heat exchanger, and we have our burner engaging, and then the blower and water is flowing, right? So that burner is kicking on, and maybe it's 199,000 BTUs. So things are starting to heat up pretty quickly, and that's what we want. We want to engage that burner, positive airflow, no restrictions. And now all of a sudden, we're trying to get all that energy and BTUs into that first half, the primary side of our heat exchanger. We do have the ability now, what we're gonna do is we're gonna hit that target wall, and on the secondary side, we're trying to really mash as much of that products of combustion into the coolest water. That side is where the return side of our system, or our closest space T's, right? It's energy in, energy out, or what flows into a T flows out of a T. So we're transferring through the process of maybe our primary, secondary piping, and then all the boiler is doing is trying to exhaust all this heat energy into that volume of water, which is usually a low volume. So, key there is that circulator is always dedicated to that heat exchanger, so we don't ramp up, we don't overheat and go off on a high limit. If you're triggering a high limit, or you're getting these constant, let's say, faults or even a lockout, that's because of maintenance. You need to understand that heat exchanger is now maybe, to say, sooted up, or just needs to be cleaned, right? Because I'm not getting that heat energy into the water. It's being restricted. There's somewhat of an insulation, and now that burner is saying, hey, I can't, I'm not able to take the heat into the water, and therefore we have safety. So they pop, and we go, and maybe we just reset, and 2 weeks later, a week later, 3 days later, in a short period of time, it just reoccurs over and over again. So the lack of maintenance, or the need for more maintenance, is there. So you can see, as we do what we do with having a signal, a call for heat, something in the building, a domestic call, an indirect, that burner could be engaging from maybe a high fire, because it is a priority. We want everything we got to go into that water to satisfy maybe a shower or something, someone high demand on domestic, or hey, we only have a couple of zones, or the house is now calling, but it's 35 out and not 10 degrees out. So we have the ability to modulate from a high to a low, or a low to a high off of that burner. And this is the process in which we take advantage of that onboard software and the computer, and what we do to set it up. There is something to be said about the other side of taking advantage of this, is giving it an outdoor reset, right? Make sure you're installing the sensors. The outdoor sensors are really giving a lot of input to what design conditions are outside. Without it, we're just basically going off on a high limit. It will modulate based off of flow or temperature through that heat exchanger, but we're not seeing the full capabilities of that modulation. So it's really best to see that, all right? And we'll talk about that in a little bit. So this is our fire tube, and this is, I'm sorry, that was our water tube, and this is our fire tube. So it's a little different of a design where it's in a downflow, right? The burners there is, if you see in the center there, that is the burner, and that whole chamber is just going to be loaded up with that hot flue products, and then flowing through. If you're looking at smaller cross sections, you see like the perforations, like as a strainer, and all that is now getting forced with the blower down through these channels, which is now surrounded by the water. Again, we have the hottest against the cool return, and that's now the big sponge. That cooler water will allow more absorption of all that heat energy into the water, which we want. And that now is going to do one thing, and I'm going to go back a slide here, is the exhaust side, right? What we want to do is reduce the temperature of the exhaust as much as possible. So here it is. If we're no outdoor reset, maybe just going off on a high limit, let's say it's 180, man, we have a lot to take out of that products of combustion to even get to the better state, the state of condensing, right? So what we want to do is lower water temperature, have the coolest water at the last stage of our combustion, and now we're exhausting all that heat energy, even in the vapor, right, of our combustion. And now we're going to turn it and collapse it into a liquid. And that again is another benefit, and I'll show you that in a little bit. What exactly are we getting out of all that washing of condensation coming back from our flue products? So here is no different. At the top is our supply. That's the hottest water going out. If it's going to our low loss header, hydrosep, closely spaced tees, and our piping, and the bottom is our return. So you see the coolest water against the hottest combustion, and that's how we're going to transfer all our heat energy, okay? And that's really the crux of why, you know, doing what you're doing, okay, yeah, I've seen some hiccups, some bumps in the road, and maybe even some maintenance issues. We got to get better at that or do it more better. But if you see the advantages of just lowering your water temperature or spreading out your delta T on your systems, I mean, these are all the benefits of what we've been doing in that first slide. We've been doing a lot, but I guess we're just missing that one extra step, lowering water temperature, all right? So by allowing the flue gas to condense, right, get some benefits here. Additional heat by capturing the latent heat that's normally just leaving up the flue or out our venting, right? Lower flue gas loss, transferring almost all the sensible and latent heat to the boiler's water. We are now in that better state of efficiency, the higher of the higher efficiency as it's labeled. Don't get, you know, tricked by a yellow tag saying 96%, you know, AFUE or something like that, because in theory, that's what it was rated for. It doesn't mean we're achieving that because we hung it on the wall, all right? The flue gas temperature is lower, leading to lower flue gas losses, right? So we're not losing anything outside. We're keeping it in the envelope, again, BTUs to match, and now we're condensing, achieving high efficiency, right? Again, with lower water temperatures, we have less standby loss as well. So the boiler's satisfied and it's just sitting there, and you know what? We have this higher temperature water. Well, guess what? It's gonna have to go somewhere, and we're just gonna lose it to the space. Call it the mechanical room, all right? So I kind of added this here, what else, right? Because there was a discussion I had, and really the benefit also, what else is, when we lower our water temperatures, we add longevity to all the components that are part of the combustion product, right? The process right there. The igniters, the electrodes, the burner itself, right? Think about if we have this higher flue temperature that has that product of combustion, right? Let's call it an acid almost. It's trying to leave the envelope of the building, and with our venting now, it recirculates right back into our fresh air. That now gets brought back into the product of combustion. And this is where we're killing really expensive equipment and the components and seeing some, reoccurring nightmare jobs because we just don't see where the problem is. And we think it could be component failure when you need to start understanding the proper installation. So here, just in a natural gas or LP fired, combustion, lowering water temperature has so many benefits for us to take advantage of. And this is what it really comes down to. Because of that high heat against cooler returning water, we have the ability to reclaim, right? Collapsing condensation. In the photo there, that's a heat exchanger, and you see the droplets, and that's, what we jokingly say, making it rain. I want these flue gases not to have the opportunity to leave the building. We want them to be as cool as possible and continue to cool so that our vapor turns back into a liquid. In our venting, it's now pointing and coming back to our appliance, our heat engine, our boiler. And now these products of flue, again, vapor to a liquid, is now washing over and releasing more heat energy into our water, which we want to take advantage of. So the turn down is key. Again, we go from a high to a low fire. We have a blower that's pulling our gas through and to the products of combustion, spark, air, and fuel. And now everything takes over. So we do want to see a wet neutralizer. That's when hey, we got a boiler that's perfectly sized for the load. We have maybe even an undersized boiler, and now it's being tasked to maybe do more than it can, but it's always going to have enough, if not all zones are calling at the same time, right? That's kind of like a weird thing to say, but think about this. On a design day, let's say 10 or 14 where I live, yeah, I'm expecting that boiler to be taxed when it's a 14-degree day and all zones are calling, right? I don't know how often I'm going to get a call, hey, the house isn't keeping up. There could be some extremes of, a selection versus load. So, I think we go towards more oversizing, grossly oversizing. And that's also not on just the boiler, but it's also on the emitters. And I want you to see the advantages of how, okay, I'm going into a job. It is a baseboard job. And yeah, I'm just going to look at the boiler that's there for the last 20 years and like for like. Well, you're going to be shooting yourself in the foot. Here you have an opportunity. You need to do a heat loss. You need to see what the house actually requires. You can even then measure up our baseboard, right? Every foot of emitter or every foot of fin tube has a rating, X amount of BTUs delivered. So now we can compare, well, the house needs X, let's give it a number and just say, 60,000 BTUs, and I have 110,000 BTUs worth of emitters. So, and the boiler that was in there was a 140,000 BTU, boiler, grossly oversized on all accounts. Here's an opportunity to shine. You go in, you show your customer, we lower water temperatures because all that surface area now, we need 60, we have 110 worth of emitters. We don't need to deliver 180-degree water. We can do something far less, taking advantage of that cooler water now, coming back to our boilers, condensing, collapsing, and now capturing and collapsing the condensation, right? And this is just a make or break line here. If we don't want to do outdoor sensors, if we're not even going to be in a condensing state, because I'm just going to peg to 190 degrees and let this thing run like we've done for the last 100 years or more, you're achieving some efficiencies, but you're not taking advantage of what you paid for or what was paid for or what was even sold. You're selling a high efficient piece of equipment, condensing. I'm going to save you all this money. And they wind up burning more gas than they ever did. So know the difference. There is that line, make or break, to condense or not to condense. So we could be up in the mid to high 90s, or we can stay down below in the high 80s. And there are differences. The end result is in the monthly expenses. Again, talking about lowering water temps. So what is that? What is that point of where do we do best? And that's basically about 135-degree return water. So imagine right now on the system side, not the boiler side, we have in our mind a high number, 180. And if it comes back at 160, so that 160 mixes with the closely spaced T's hydro-sep or low loss header or something like that back to the boiler. So I'm now engaging the burner to about 160-degree water. It's going to do something, but not everything that it's engineered to do. So see where you can, again, envelope over equipment, heat loss, size up your emitters, and start understanding lowering water temperatures. And really, as you see the line here, that green dotted line, the vertical line there, dew point of natural gas is roughly about that 135. So the lower that you continue, and this is maybe where outdoor reset now, taking advantage of having something outside, telling the programming, hey, you don't need to be in a high fire, you could be in a low fire. So now we're starting to now really collapse and condense and take advantage in that higher state of high efficiency. So you can see there the condensate mode is 135 is best to be to the left. If we had to be something higher, yeah, we can be at certain portions of our heating season. So you think about how often it's a design day of 10 degrees outside, it's really small. So it's okay if the boiler needs to operate there, but for the amount of runtime or firing, throughout the season, how many, hours of operation, and I'm mostly to all the time being in the condensing side of that graph, that's when we know we're winning. That's when we see the neutralizer wet. That's when we see, we have a trickle of condensate that's been, neutralized back and down the drain. Neat stuff here, right? So boiler return water temperature determines the condensation operation, right? It's all about what we do on the system side, the thing that's been there for the last 35 to 50 years. Take a good close look and do a heat loss there. See what we're dealing with. Is it fin tube? Is it radiant? Is it hydro coils? Panel rads. There's a list of emitters that we might have options with. It might be a mixed bag of stuff. So we really need to see what the house load requires, what our emitters installed are allowing us to have an output of. Yeah, we can peg it and do 180, and then we're going in the opposite direction, right? Energy and comfort. So the comfort level of what we do sometimes in overheating a space can just do the opposite and make people uncomfortable. So slow and go, not fast and furious, right? And here's just a kind of regurgitation of that, again, make or break 135, but look at what you're doing now, really achieving some higher efficiencies, and that's fuel savings. And that's where, why we upsell people and we tell them about what they're gonna save, right? And in addition, give them great comfort. So that 135, think about it, man, it's like I don't feel comfortable with lowering water temperature. Maybe that's why you're here today, My goal by the end of whatever, an hour's worth of me talking is I want you to have more questions, right? There's got to be something that's going to trigger you to go, I didn't know that. Tell me more. Or, hey, I will look at the installation instruction manuals. What are the manufacturers really stating? Why is there a big target on PVC versus polypropylene? There are a lot of things. I don't know, where do you get your information from? Are you self-taught? Are you someone who reads manuals? Are you an engineer? Are you on social media? Are you listening to people and just taking their word for law? So it may be all the above, but you got to make a decision where you want to stand. You want to be a follower, you want to be a leader. And sometimes being a leader can be a little scary, but their rewards are big. If you're out there you can set the playing field for your clientele. You can have confidence in what you're installing because you've been doing what you're doing already for 30 years, right? How about change it just a little bit, and you're going to see some really big changes like, wow, I don't get those, nuisance calls. I don't have to go out there in the middle of a winter night because electrodes have failed, and then what is the idea? It's like, well, do you investigate what is the failure? Why is this happening? Check the venting out. Look at your venting. Now, natural gas over LP might have another, set of rules as far as the product of combustion, but that's for another day. All right. So yeah, for condensing boiler, you need to return water temperature of 80 degrees. Imagine that. Having your systems delta T. Imagine having a system that is designed around 120-degree water. Blows my mind, right? But it's doable. Envelope over equipment. Today's buildings, homes, structures, envelopes are being built for high efficiency. Spray foam, better windows, siding, all the insulation, just the envelope of the building is being just that, becoming a thermos, zero loss. So we need to understand, really, in doing a heat loss, you'd be amazed. You probably won't believe how small of a number when you do a heat loss. There is a heat loss, and then there's the next level, which is a blower door. Blower doors are really for infiltration. Again, in older structures, a lot of cracks, windows are not sealed up, there's a lot of loss. Warm goes to cool, and that's just the natural progress of, Mother Nature here in the dynamics of heat loss, right? I'm not say pressurizing, but I'm trying to maintain temperature in the building against a much cooler outside temperature. Air, warm, will find its way to cool, always, all right? With the process and which and how, and to get to that, and outdoor reset and collapsing, right? Wanting that flue products to be as cool as possible so that we can take advantage of what we call the latent heat. The loss that is typically leaving the building is fuel we paid for, right? How do we reclaim this? How do we achieve in those high 90 percentile of efficiencies on our equipment, right? So imagine having a pound of 212-degree water and it changes state, right? 212-degree water and 200-degree vapor is still the same temperature, but it's that transition or changing of state from a liquid to a vapor. When it has that transition, as you see, vaporization, the condensation there, that's latent heat. There's a releasing or even a gaining of 970 BTUs. So for a pound of this changing vapor back into a liquid, washing condensation across our heat exchanger, there it is, 8.33, 1 pound of that condensation releasing that 970 BTUs, it's an additional 8,080 BTUs back into my system, right? Back into the house, not just leaving. So if you do your calculations and what that means, I don't know, a heating season of 2,000 hours and runtime or whatever, this is really, man, that's something to be a goal of. Seeing more of that wet neutralizer on any given day, not just a design day, or imagine having a design day of 10, but I only need to satisfy the house with, on a design day of 10, maybe 135-degree water. But as now the outdoor sensor takes over, hey, it's not a design day of 10 degrees, maybe it's an average winter day, let's call it 35 degrees out. Do I still need 135-degree water? No. Maybe because the building, the envelope, only loses, it loses more on the coldest day. It loses less on a 35 day versus a 10-degree day. So now I only need to deliver 100-degree water, 108-degree water, 110-degree water. So imagine now what we're achieving on that product of combustion now, and condensing, collapsing, and just going in the right direction now. All right.
That kind of goes to Russ's question, asking, what type of emitters would return water temps of 80 degrees? It's really anything that could be satisfied with a 100-degree water temp and a 20-degree delta or something.
100%. So I'm going to show you, and this is again a regurgitation of what I did back in April. So I'm really hoping there is going to be a flood of questions so we can engage when this is over, right? It leads you to engage, maybe talk to your manufacturers, talk to your manufacturer's reps. Who do you work with the wholesaler wise? Talk to, Rick and myself. That's really why I asked you in the very beginning with the QR codes. You want to have an engagement? I need to know who I'm talking to. I'm not here to spam you. I just know when I pick up the phone, I met you somewhere. It's just the way I roll. Here's a question for everybody, right? If you would never think of lowering water temperature before, I ask you, why is it okay with radiant, right? Why is lowering water temperature okay there, right? Think about that. It's surface area. The amount of surface area in the floor, 9 inches on center, 6 inches on center, commercial, 12 inches on center, 24, it's all based on what the load is. BTUs per square foot of this space, I can now lower water temperature. The other reason is because too hot of a floor can be very uncomfortable. So here, what is the lowest temperature water you have on a radiant job? Think about that, and then ask yourself, why can I do why can I do this water temperature here, but I don't feel comfortable forever and ever with baseboard, with panel racks, with towel warmers, with hydrocoils. Grossly oversized emitters have to be more surface area. Because of that surface area, I now can use lower water temperature and still achieve great comfort. Remember, energy and comfort, that's the business. And it's gonna get challenged in the next level, right? This is just part one of, now part two is gonna come up in a very, couple minutes here. So this is some of the numbers I've worked with. I've done radiants, right? I've done a lot of heat loss. I've done a lot of radiant projects, snow melt, right? It's not unusual, right? You only need 110, 120, maybe 130, depending on the application. Staple up, plates, embedded, quick track, maybe like a dry plywood approach. Snow melt again, great outdoors. I did some patio cooling for a customer. They wanted to chill the patio around the pool so that the people wouldn't burn their feet. So there are people out there that have money to burn, obviously.
I want that.
Yeah, right? Any questions or any popping in? Okay. So to embellish a little bit more, and just the process again, just talking about something as lowering water temperature and what we need to do, and even having the process, you have to understand what the combustion analyzer is doing for you. It really sets up the CO2, which is where we're setting the bar, or how quick or at what temperature will we see the collapsing of flue products, and that becomes condensation. So this chart here is just showing you, based on which manufacturer installing in their installation guide, they're requiring with the combustion analyzer that you set up the burner. They might do this at the factory, but they don't have the same quality of gas that you do have on the job site. They don't have the same quality of air that you now have on your job site. They're certifying something before it leaves their factory floor. It's up to you now, one, when commissioning, and I would suggest on every time you do a maintenance. If you're touching the equipment, these things come with printers, it's liability now. there are things that you just might see. And as I say, anything that ends in your honor really isn't a good thing. So now if you've done your due diligence, you're getting paid for a service, you have this equipment, make sure you understand how to use it and properly set up your products of combustion regardless of fuel type or type of equipment. And that goes for oil, it goes for condensing, non-condensing, natural gas, LP, right? All these processes have that threshold. So the green line shows you here the dew point, right? So it says CO2 volume, the percentage of 10. I have a range. Now it goes from 8 to 10 there, that other dotted line in red. But look at the water temperature now. The green is roughly that 133, 35, let's call it, to about 122. Now this is the returning water temperature, right? The flue products leaving. Well, if I set it to 8, I'm waiting longer now to collapse the flue products to get that higher efficiency. So why not see, hey, I can now be the governor. I'm going to set it within the parameters this manufacturer states. And yeah, I like to see it quicker than later. So that's why you see the difference between the green and the red. There's a range there. Nothing's perfect, right? Because again, at the time, even when you're doing it, quality of air and quality of fuel is now right there at that particular time. It could change, but you documented. That's the point. You now have that snapshot. I've proven this is what I did at the time when I closed the equipment up and gave you an invoice, right? So just look at that differently. This is in every installation manual, installation instruction manual based off manufacturer. They're giving you these numbers that they want you to calibrate and set up when you're on site, okay? Regardless of fuel or type. This is an old slide. I just really had some fun building this, and the mindset was back really before even lowering water temperature, selling outdoor reset for cast iron boilers. Partial reset, right? So cast iron is typically a non-condensing boiler, and there's a threshold. I don't want to go below 140. It's cast iron. If I'm condensing, I'm almost deteriorating that cast iron, as strong as we think it is, but over a short period of time or a lifespan less than what we typically see for cast iron, we could be corroding because we're condensing in a non-condensing piece of equipment. But we had these devices, right? We had these ability to add to even a cast iron boiler. So I was asking people, why do we need 180-degree water when it's a 40-degree day outside, right? Allowing something now to see the outdoor temperature. I agree, on a 0-degree day, we need 180. I get that if that's what the house needs. Again, we have a threshold with that piece of equipment. I'll say it again, 140. That's, you don't want to go below returning water on a non-condensing piece of equipment because it will condense and now we short life the equipment. So here is just showing you how do we now have the ability not to modulate, right, but just to end the end switch, the signal to the boiler operating controller, aquastat if you want to call it that, okay? So I had this device, an outdoor sensor, and now I was able to ride, here's that thing, an outdoor sensor, call it Alroca, right? That's giving a microprocessor, which is now controlling the signal from, let's say, a switching relay. Instead of going directly switching relay to the boiler, there might be this microprocessor in between. And this is seeing outdoor temperature. It has a sensor that's seeing maybe return water temperature, I think, or supply water temperature, I forget which. And now it goes, okay, hey, it's not 0 out. I don't need 180. It's something warmer out. I only need 150-degree water, not 180. So I'm not having to keep firing and losing and not taking advantage of the fuel being spent. So, and also going back to on a warmer day, Oversized emitters, pegging 180 or higher, you're now creating maybe an uncomfortable condition as well. You know, the other side of it is that when you hear a boiler, now it's funny, when I go out of non-condensing, right, I call it a boiler. When it's in condensing, I go to a heat engine or something like that, or high efficient. It short cycles. It's just grossly oversized, right? The heat can't leave the building quick enough. Comes back warmer, satisfies the boiler. And that's where we get in trouble. So this next slide here, bigger isn't always better, right? Low temperature doesn't mean low heat. Holding those two coins in your hand, this is a perfect visual aid, right? The dime is twice the value of the nickel. Bigger isn't always better. And you gotta see that. You gotta start seeing that. Because what I want you to do here is investigate more, ask more questions. If you're a baseboard guy, and I've been always living in that 180 world because that's what I was told, you've been told some lies. You have to see the value of what a spec sheet can really open up for you based off of whatever manufacturer, whatever model of that manufacturer's fin tube, right? There's different models. I know my manufacturers, you know, Petite 7, Petite 9, you know, we have all these different models, but basically what it comes down to is fin, what size element is on that piece of copper? What size copper is important because of flow? But here, if you look on this chart, and there's a 3/4 inch copper, basic number 30, I believe this is slant fin. So slant fin makes a 30, they make a 15, a 30, they make an 80, you know? Why different numbers, different ratings? Not all BTU, not all baseboard is equal, is created equal. Know the differences. Again, I'm doing panel rats. I'm doing, hydrocoils. All these things have ratings of flow versus temperature. So if you look at the chart here, if you live in that 180 world on a 1 GPM flow rate, the top there, it's saying 580 BTUs per lineal foot, not copper tube of the actual fins. Well, you know, if I had a room 10 foot, that's how many BTUs? 5,800 BTUs. Well, the room only needs 2,000. And every time the boiler fires and a circulator comes on and that zone calls, I'm overheating the space, regardless of a design day or a mild, 35-degree day in the winter's month, right? So now short cycling and efficiencies, it just all goes snowballing in the wrong direction. What we can do, even taking advantage of something that's been installed, inherently grossly oversized, is lower water temperature. Again, if it's cast iron, I don't want you to go below 140. So let's just use that mark. I need 2,000 BTUs in 1 out of 6 rooms of this zone. If one room is grossly oversized, I can only imagine all the other ones are as well. So let's just take a cast iron piece of boiler with baseboard, 140. That now delivers 320 BTUs per every foot of baseboard. That room with 10 feet, that's 3,200 BTUs. I only need 2,000. Again, on a design day. Again, design day of 0, 10, or whatever you want to choose, wherever you live, right? It's a good question in the chat. Where are you coming from, and what is your design day temperatures? Are you further north? Are you south, out west, Colorado, elevation? Where are you guys calling from or logging in from, and what is your design day conditions? Get familiar, dive a little deeper with the information, and stop listening to people who maybe have half-truths. Be your own, decision maker here. Be a follower or be a leader. There's a difference. The view is far different when you're the lead dog, right? Think about that. This was a slide. It kind of went south for me. The pendulum used to swing here, so I kind of just killed the animation. But, balance is not given, right? It's designed. Efficiency and comfort, right? Energy and comfort. That's really maybe what it should say. But efficiency or energy and comfort is the business of win. How do we get more in tune with not just doing something and making a statement, but how about doing it and believing it, achieving it? And I would say, regardless, you don't want to be a believer, start listening to your own house this winter, and you're going to hear that boiler short cycle. And you'll remember, go to that boiler, look at how many BTUs. Never did a heat loss? Do the math. Get involved with a program, not actually do blow a door, start somewhere. And I tell you, you're not going to trust the number. Like, no way, I can't believe this house only needs 42,000 BTUs and you have 150,000 BTU boiler sitting in your basement. And then the answer will tell you why it's short cycles. Turns on, turns off. Every 8 seconds, turns on, turns off.
We got Russ upstate with a minus 25.
Oof. How far upstate, Russ?
That's what I asked him.
Canada? Minus 25.
We're from Long Island, so anything north of the Bronx is upstate. North of Utica.
Oh, that's
Okay.
great. North of the
Minus
Bronx.
25.
Holy Moses.
Keep that up there, Russ.
All right. Part 2. Get your thinking caps on. This is going to scramble egg you all day now. To think of what a modern heating system is going to be in your very near future. A hybrid, maybe existing or maybe a new build, right? Think about where things are going to progress to. We are looking for smaller envelopes being tighter, heat loss being minimized at all turns. New builders, new developers, right? So here it is, lowering water temperature, air to water heat pumps, part 2. This was a chart and it kind of shows you water temperatures, right? What's required to our heating systems on a design day, right? That nice up the middle there, right? 120 degrees. I'm not saying we can't pivot off of that under extreme conditions and go a little higher with air to water heat pumps. Now, I don't know if anyone's really diving in or seeing this technology yet, or has ever been to a training class, or has ever actually installed one. That would be just the first time having a discussion or being part of a discussion of air to water heat pump. When you see heat pump, that typically means electrification, right? Using a refrigerant mechanical device powered by electric, having outdoor air, free energy, even in the minus degree days, with the chemical compounds of our refrigerants, the ability to absorb that heat energy and put it into the refrigerant and deliver it inside, into our homes, to an emitter. We may have been familiar with the explosion for air source heat pumps, right? We're now liking even better because of what we've been doing inherently, pumping and piping with the boiler, right? With fossil fuels. Now, kind of shifting, watching where we need to go, mandates, electrification. Right now, I mean, there are pitchforks and torches in a lot of local organizations because of local law, some of them in New York City that I live near, local law 97. Certain buildings at a certain height, I think it's what, 7 stories? 7 stories or less are not going to have fossil fuels. It's mandated. I also understand there's going to be some kind of scorecard for pre-existing buildings, for carbon footprint. Where do you rate on our test? And if you do not conform, right, big brother, you're going to get a penalty. You're going to get your hand slapped, and there are going to be some hefty fines. So they're really starting to shift and force what we just discussed here. The envelope over equipment. And we have to prove our selections. You can't put that boiler in because you now have to submit a heat loss. Municipalities are requiring for a permit, you need to show what the envelope's requirement is. And then the equipment, you need to prove why the selection for that. So, there's a lot of change. It's, I say, near now future. Yeah, it's more near than future. It's definitely happening, right? So we need to see why traditionally all the way to the right side there, man, we're gonna get in a in an uncomfortable area before we get comfortable again. So today I hope again to lead you to more questions and follow up and investigate for yourselves. What do I do in the very near future of supplying? Your customers might be insisting. Do you not want that business? Don't live with horse blinders, live with an open mind, 2 ears, 1 mouth approach, right? Listen a lot more than you voice your opinion before we really dive into this stuff. Now that'll never work. I had people with my air source stuff. I represent Fujitsu, so people used to come in, well, that's really not good heat, right? I'm like, well, what do you mean? I'm delivering BTUs. See, we get locked into temperature, right? No, I can't do that. I can't low water. I need 180. Like, no, the space requires BTUs. And if I can deliver BTUs, that's all that matters. A BTU is a BTU is a BTU, right? Regardless of our source, getting better again, envelope over equipment. So here, just if you never knew, how does it really work? Air to water, very similar to air source. We have the great outdoors. We have a plentiful amount of free energy, even in the coldest of winter. Our chemicals, the compounds of R410A, has the ability to absorb heat when we look out the window, and I just can't imagine being outside, right? Minus 25 for, up further north. So, excuse me as I wet my throat over here. So what we do is we have the ability to force air across a coil, one side air, one side refrigerant, right? And that process is now going to chemically change, superheat under compression. We have a compressor, right? Anything we compress creates heat. That heat then is transferred to an emitter indoors. Could be baseboard, could be a coil, could be anything. Could be a buffer tank, right? Buffer tank could be a storage tank. Imagine doing not only heating with this piece of equipment, but the new modern condensers, or they're heat pumps, right? They reverse the cycle. So in one season, in one mode, it's creating heat. And in another season, we reverse it, and now it's creating cooling, right? So now we're doing both seasons with one piece of equipment outside the house, right? Neat stuff. This chart, and this is something, again, we need to expand and get a little deeper into acronyms everywhere, right? Like death by PowerPoint, it's death by acronyms. So coefficient, COP, right? COP is coefficient of performance. It's a rating. Because we're electrically powered, okay, well, how efficient can this actually be? Electric right away, if you do an electric water heater, if you're on the plumbing side of things, versus a natural gas or oil, products of combustion has to leave the building, right? It's a safety thing. It's a natural progress. As high efficient as it can be, there is some portion leaving. With electric, there is no byproduct. It's 100%. So coefficient, if you have coefficient of 1, that represents 100% efficient, right? Energy in, energy out. That's what we're really focusing on, the energy out. How can I take advantage of that? The chart to the right, it's showing you our heat pump heating capacity, right? There's something with an arrow saying balance point. Eventually, we will degrade or reduce the output because of our limitations with refrigerant. It's a natural thing. It can only take us so far, but it could be upwards of 200% efficient up until that point. And then we might need some kind of backup, right? And we do have modern day heating now with just that. So I'm going to show you some things here. So not to kill you guys, I don't know where you're sitting right now on your cell phone, in a car, a van, whatever, but that chart there saying high COP 2.50 plus, right? Outdoor temperature, that looks like it's a 15-degree day. And now anything less than that, yeah, I'm gonna still do whatever I can, but I'm gonna need to maybe trickle charge. Again, look at the extremes of that design day, and colder now, it's so far and few in between. We live mostly, let's say, in that 30-degree, 25-degree outdoor temperature. And if you go up to the line, you know what I mean? You'll see where that heating load line is. And that's where now we're really taking advantage of that heat pump. The refrigerant is so efficient in which and how they run. Inverter heat pumps, right? Two-stage heat pumps. There are differences on that side as well. If you're not, I'm not a refrigerant guy, that's okay, because a lot of our equipment that I'm going to show you in the next few slides, it's sealed. It has the refrigerant. You don't have to touch it. All you are now is that heating guy on the energy side as well, and you're doing your pumping and piping. Let's open up that installation instruction manual and go, okay, I need a pump to flow a minimum of 8 GPM. That's my job. What pump in our world does 8 GPM and overcomes head resistance, right? Nothing new. We've been doing that forever. Pumping and piping, using a refrigerant electrified heat pump now and get that heat energy out of. And this is something cool. I just thought it was catchy. You know, harvesting energy from the air, right? The volume of outside air, regardless of a minus 22-degree day. We have heat pumps that will operate and produce BTUs even in the minuses of 20s degree days, right? So our input of electric is one portion absorbing two other parts, right? So my input of power is one, but yet I'm now getting 3 units of energy, heat, let's say, or cooling maybe, depending on the mode. That's where we're going. We're doing far better refrigeration-wise, transferring of energy than we've ever done with fossil fuel. Ever done, right? And if you're not comfortable, today is day one. You're gonna be uncomfortable before you get comfortable again. And that's just the nature of the beast and what we're doing today with modern heating and even cooling pieces of equipment. I threw this in here because I was trying to come up with some catchy things, and even just to keep myself entertained, because as I do this, you know, it's regurgitation. You know, it's like anything else. It's a muscle. You use it a lot. After a while, you got to start changing up your exercise routines. So I jokingly have this thing like, how hot is a kilowatt? We're so focused on temperature because I can't believe lowering water temperature. I'm not going to be that guy. I don't want the phone calls. I don't want people complaining. Well, your heat loss proves what you need to deliver. And that's not temperature. We're not delivering temperature. Every foot of baseboard has a BTU rating. This room requires 2,000 BTUs. So how hot is a kilowatt? Well, it doesn't make sense, right? It's like, no, that's, what do you mean? Well, kilowatt equals 1 kilowatt of energy converted to a BTU an hourly is 3,412 BTUs. So using something now, a heat pump, inverter, 2-stage condenser, whatever we have, a chiller, right? We're gonna start seeing the product that maybe is gonna, like, no way, I'm out of this business in 3 years. Like, you're already setting your exit plan because the change of the equipment. I'm sure there will be people that wanna do that. There'll be people who wanna see the opportunity and maybe be the leader and get involved with training, get involved with some of our manufacturers, your local sales representation, you know, challenge them, you know, ask those deeper questions. Prove to me why this is gonna work. I have a project. I'm thinking about using it. Let's take it for a spin. Show me, right? Make me a believer. So for 1 kW, there's 3,412 BTUs. Let's say 1 ton of refrigerant, right? 12,000 BTUs, 1 ton, that's 3.5 kilowatt, right? So associating across different sources makes us more comfortable. That's why I did this. So how hot is a kilowatt? It's a trick question. Oh, this is one of my manufacturers called SpacePack, and they have been probably in the forefront of air to water in a residential aspect of what you see here. They've gone through a couple different versions because of new development, right? Better performance. They have 3 different areas in which we can offer. Solstice is their kind of tag name for their product line. And these are air to water pieces of equipment. You notice there's another handout block there. And again, if you haven't taken away, there are 5 handouts. One would be our line sheet. Rick and my information's on there, amongst others, and also all of our manufacturers. Today is not just for today purposes. It's to build and grow. If you're local, get involved. We had a parking lot event last Wednesday, and we did this residential splash, if you would, of all things for lowering water temperature, high efficiency. And we had training classes. We had 40 some odd people show up on a Wednesday and stay for a good portion of the day. I had some guy come from Goshen, which is not around the corner, and he got up early and drove out to Long Island to come be a part of what we were doing. And I saw light bulbs go off in this training session for NTI, because again, high efficiency, right, using combustion. We also did a SpacePack, and we also did Electro, which was our electric boiler offering, which is quite cool. But here is SpacePack, right? There you see the website. Good company, good people. We like working with them. They have this really cool offering, air to water, 3 different styles. Here's one of them. It comes in 2 different models, SIM 036 or 3 ton, and the 060, which is our 5 ton. See some of the BTU capacities there with an asterisk. We need to dive a little deeper, right? When reading this stuff, it might sound like, wow, all right, now I'm in because I can do 70,600 BTUs. Understanding what that asterisk represents, right? There was a test to prove that we can do that. What was the test parameters? What was indoor temperature? What was flow rate? What was outdoor temperature? These are those deeper dives that we're going to be needing to do. Now, that's a conversation you and I can have. You can have with Rick. You can have a multitude. You can have with SpacePack, right? So this is that engagement after today. How do I become more comfortable with this? Because I do see the market change. Further up north, believe it or not, in colder climates, this has probably been the biggest seller. There are incentives and rebates. What is it, like per ton?
Depends on the area.
Right, but the extremes, I heard like $3,000.
Up north, yeah, $1,000 a ton.
So like they're paying for the equipment.
Yep.
It's something not to be ignored, So what do we have here? DC driven compressor inverter technology. These are monoblock. So the refrigerant is on board from the factory with this. You're bringing your water piping outside. So yeah, there might be some glycol involved, right? We can do 42 to 130 degree delivered water temperature. So lowering water temperature is a must here. Maybe you just want to do partial load. Maybe run this, again, for the majority of our heating season when it's mild out. And then, hey, I can incorporate the existing boiler. I can have something as a backup to now when it's colder out and I need something more than 130. There is going to be these handshake moments. Fossil fuel to now heat pump, right? Or chiller, depending on where we live, right? Because this is a reverse cycle chiller or heat pump. Again, Southern, they call it a chiller because of majority of their season is for air conditioning. So they call them chillers. Up here, we call it a heat pump because we might have the ability to do both. Or majority could be in a heating purpose, right? So just see this stuff as not, I'm never going to touch this. You start denying it now, forget it. I had people in a training class. There's a father with 2 young boys, and it's a story I tell because I witnessed this man glazed over look. He's a 40-year plumber doing heating. In his world, everything's got to be high temperature. And his boys sat behind him in this training class, and I was watching him, and I heard he was just getting overwhelmed. You can see his face was just, his expression was like, oh my God, you know? And I walked around the room, and I literally landed right in front of his table. And I said, who in the room is not comfortable with lowering water temperature? And I literally moved into his visual. And he said, yeah, I'm not. And I said, I know, I can see it. The problem is your 2 boys can see it as well. And they're the next generation. So you gotta get comfortable so they will follow your lead, you know? So there's gotta be some kind of stepping off. You wanna continue what you're doing, that's fine. But there's a lot of opportunities that are just gonna go by us. Or we're gonna be forced now, you know, stamping our feet and saying, no, no, no. But the truth is, there is means in which to get you comfortable. Training, as we're doing today, manufacturers, you know, going to them and sitting and listening, having live fire equipment and watching the machine actually operate. It's pretty impressive. So this first offer had 2 sizes, 3 and a 5. This is our monoblock. This is their mid 4-ton, and it's our low ambient. I think this one, if we go back, is like down to minus 13.
Close.
Something like that, minus 13, and still performing and delivering. And now we go here, and this one goes down to minus 22, still with 130, as not necessarily on a minus 22 degree day, okay? There is a slide that I'm only gonna produce, you know, with the outdoor temperature that I can absorb and then add, right? Can only do so much. So we need to understand where our design day temperatures are, what our heat loads are for our envelope, and then we can design around that. That's where all things start. It has to be, right? But look at COP on these, right? If we go back, COP for the 3 is upwards of 5. Remember I said a COP of 1 is 100%. This is telling me this equipment can operate at a certain state of outdoor temperature and water of almost 500% efficient, right? So you see the 5-ton there, it drops a little. Now we're only at 460% efficient. So this is that game changer of why we need to start seeing this. We're going to educate not only through the industry, but the education now is going to start going to the end user as well. And they're going to start asking you, can you do this, right? Don't lose those opportunities. Even on this low ambient one, again, what conditions of testing did they prove a COP of over 500%? That's really what we need to see, the truth, right? Okay, yeah, work it back into my design. I'm still over 200% efficient. That's double any just electric piece of equipment, electric resistant baseboard. Forget fossil fuel, you're in the high 80s. You're losing money. Here you're gaining, okay? Now this one's unique. This is their SIS. This is what we call a split, where the outdoor unit and we have an indoor unit, and it's connected with a line set. So if you are on the refrigerant side, or maybe you have something installed in your house, you know what that piece of copper, the pair of copper lines from outdoor to indoor, we have limitations, we have elevations, so roughly about 35 feet. That's as far as the connection from outdoor to indoor is. But this is a 5-ton. It's got great performance. You can see cooling capacity, heating capacity, and the COP here is upwards in the 3s. So that's 300% efficient. This is a minus 20 turned outdoor temperature. So we have some really good efficiencies, delivering even upwards of 130. But what if it's only 120? Well, that's okay. We just heard about lowering water temperatures and the advantages, and envelope over equipment, and designing based off of emitters. A BTU is a BTU is a BTU. Don't worry about heat. Worry about delivery of a BTU. Can we produce it, and can I deliver it? That's the new goal. This is a look of some of the accessories that I can offer as emitters using water. Outside, refrigerant, air to water. There's our buffer tank. Think of the buffer tank as what was once the boiler, right? The outdoor unit is only looking at that buffer tank, maintaining a temperature to satisfy the limit, the aquastat. By having that temperature is now the battery, right? That's our resource for all emitters in the house. One zone, micro zone, all zones. We need to see the better practice and purpose of doing a heat loss, room by room, zone by zone, or whole house, okay? But here we have something, look at the upper middle block. That looks like a mini split. That's a cooling or heating hydrocoil with a blower, with a remote control. It does require 120 degree power. Sorry, 120 volts of power, not degree, right? The lower one, I don't like it up high. I can have a surface kind of looking like an old convector. Again, these are, modulating blower, fan speed and things of this nature. Really high output of PTUs here. You want to compare, I don't know, baseboard. People maybe want to get away from it. They don't like the look of it. It takes up all the wall space. These things with certain water temperatures, not for today, but the charts like the baseboard I showed you earlier, all things have spec sheets, has a rating, right? And certainly we can do upper right there, a hydro air handler, which is really what SpacePack was, core business, high velocity air delivery, right? Cooling and heating. We now just deliver hot water, or we now deliver cool to cold water. And then we distribute through small ducts, and out we go to the house, right? To make you a believer, or never seen, maybe, hey, I don't know yet, what does this mean look like? Well, the right side is the outdoor unit, elevated for snow loads, free air, getting it off the ground. Maybe it's not snow, maybe it's water, maybe it's for flooding, right? So there are purposes why it's off the ground and what we need to do there. The left side is basically the mechanical room. And man, if that doesn't look like a boiler room, everything's there except a boiler. That indoor unit is now the air to water, right? There's the refrigerant exchanging with the system's water or glycol going out to all those zones in that picture. Now the thing in the middle, there's the buffer tank. That becomes the battery. We draw off of that to deliver to the space, to the home, to the building. That's going to be maybe a unique add to anything we've done with a boiler. Buffer tanks have been around. That they're nothing new. It just has a rebirth because of what they once were to not so modulating wall-mounted boilers in the past, right? Having too many micro loads in a house and short cycling and so forth. So that's what a buffer tank does for us. It creates a volume of temperatured water that satisfies the space. And all we have to do is maintain and trickle charge or maintain for the load increasing. The load in the room, the house, the building, more zones open up. Well, that chiller is going to kick on, and we are going to offset that cooler water in that buffer tank, and we're going to superheat or supercool that tank there. Now, there's one thing I just want to point out, and in the picture to the right, you notice the PVC snorkel off to the left side there. There could be a need for an additional backup, something for when it does get to the extremes of the minus teens, right? Further north, as we heard, minus 25. Well, maybe I have redundancy. I have this for 90% of the winter, and then in turn, if I should need, I have the handshake, right? I have the ability now to turn on that boiler and now satisfy when I need 160. 120, 125, yeah, the house load is increasing, I'm not keeping up, turn the boiler on. Now, fast and furious again, but only for the short windows. So now we're achieving better system efficiency running our heat pump more times than we are fossil fuel. I'm not against fossil fuel. I'm okay with leaving. If it's there and it's got life in it, leave it. Marry it to what we're going to be doing, a hybrid, right? Okay. So electro, I guess we're closing into 2 years with this venture as a manufacturer's rep. COVID hit everybody, and this was a manufacturer that came on board, and we didn't get to see or really meet and listen to this manufacturer. It's a one-man national sales manager, Dennis, good guy. And when he came in, it was like a full court press. We got to meet him. I heard the story. I listened to about, I don't know, a year's worth of webinars that they offer. And speaking of webinars, right there in the middle, this is a snapshot of their website. And just tomorrow, take advantage of, electromn.com. And here you go. You have what you should know before replacing a gas or oil boiler with electric boiler. They're gonna take all the smoke and mirrors out of, why would I want to do this? How does this make sense in my world? I'm an oil guy, I'm a fuel oil guy, or I'm a gas guy, This electric thing, it's never gonna go. Well, I'm telling you, it's going, it's happening. Remember the near now future? Yeah, this is the now. This is not even the near now, this is the now. But air to water heat pump boiler. This is one product in a small offering. Those little houses down there at the bottom, it says, goodness, I can't read it. Heat pump boiler, electric boilers, makeup air, and what's that last one say? I can't read it either. Whatever.
Check
I think,
it out.
Move along. Norair is the product name, right? You have your choice of heat pump condenser outside, preferably a 2-stage or an inverter. You see the line sets going into the indoor unit, and in there they have this coaxial coil heat exchanger. And the refrigerant is on the inside and the water is on the outside. So you have this direct contact of, again, hot flue gases or even cooling, you can, right, if we have the right emitters. And now we have this heat exchange in a very, again, efficient manner, absorbing free energy, utilizing our electrification, right, powered by electric, and transferring into water to do low temperature approach. I mean, we can prove, if I just kind of toggle back here, maybe I should repeat this slide instead of doing this. Look at all the options we have here with lowering water temperature. Certainly have radiant in many different applications, right? Wall heating, again, it sounds like it's doing radiant. Panel rads, here it was an emphasis on space pack, but you could even possibly do some baseboard applications depending on the load versus emitter. How many feet of baseboard can I deliver the BTUs with even 120 or 125 degree water, right? And in being above 100 to 200% efficient. And this is what the premise is here. So Norair, Electro Industries out of Minnesota, everything is manufactured right here in the United States. Again, get involved. Tomorrow's webinar might be something as a starting point, but here's that a little bit of a splash and all the different things that we can do with air to water using refrigerant now. Neat stuff. Here's the climate. Think about where these guys are in Minnesota. I think it gets a little cold out there. the land of 1,000 lakes, I think, if it's Minnesota, if not the nearby surrounding states. But they're been doing this since 1974. Electric is big business outside of maybe the local area here in New York. It's costly. For me, I didn't become a believer until I sat through webinars and I saw applications. For me, and I'm an applications guy. I'm a kid in the candy store, right? I have all the abilities to do a heat loss. I understand what the structure needs. Now is aesthetics, the looks. What can I do for remote buildings? Trenching and running gas lines, putting LP tanks on remote buildings. Well, you know what? There's electric out there. Small little areas or small loads. These things range from 3,400 BTUs, an electric boiler size, 3,400 to 1,000,000 BTUs. Can you imagine? So NorAir is one of the products that they offer. It's their air to water though. They have straight out electric. What needs to know here is they do have, if you choose to buy it, an electric boiler backup within this one component, the EBHP. So I take advantage, if you look at the chart down low, the green is the outdoor heat pump. Again, 200% efficient, running to a point of outdoor temperature dropping. Hey, I'm just going to trickle charge with the electric boiler. They have something called warm flow technology. As a manufacturer, they manufacture and engineer all their own controls. So having KWs, remember 1 KW is 3,412 BTUs. Well, what model are we picking here? I can have upwards of a 10, a 15, or a 20 kW electric boiler. So break it down, a 5, 10, 15, or 20 kW. They have banks of 5, right? So elements. In a 20 kW, there'll be 4 or 5 kW elements. Their technology, the warm flow, that first bank, always that first bank of 5 is modulating. They have a triac relay, and it just trickle charges based off of water temperature. So why am I utilizing maybe costly energy, right? From the utility pole to my house, let's say it's 22 cents. I mean, that sounds crazy, right? Versus now, well, what's the cost of fossil fuel? What's the cost of a gallon of oil? What's the cost of a therm of gas, right? Or LP even. Everything's expensive. So that's why we're going to have this ability to handshake. The control strategy says, well, you know what? I can set a parameter at a certain outdoor temperature that I'm going to go to fossil fuel. But that's such a small window. So otherwise, I'm going to use, electric. Think about how many homes that maybe your customers or have photovoltaic, PV solar on their roofs, right? And they're offsetting their electric every month to the grid. These are things that we need to see as opportunities and tap into. Partner with maybe a PV solar company, right? So these things are great producers. As you see to the right, there's our 4-ton, has a range of 242 to 297% efficient. What is the COP there? I'm gonna move in. I guess it's 2.9 COP, right? 297% efficient. That's 2.9 COP. So again, flowing at a certain rate with a temperature rise of an outdoor temperature of. There are these things. Again, dive a little deeper. So again, everything is expensive. Don't be so like I was. Maybe the horse blinders are on way too long to even see electric as a means, right? So the technology, we use it, and I see it on my air source side, my Fujitsu side, but I just never thought of it until maybe in the recent 2 to 3 years with air to water. It's pretty neat stuff. So there's a coaxial coil again, the amount of surface area, refrigerant in direct contact or in transfer contact of water, right? Hot flue gases to our water, transfer energy out to our buildings, make people comfortable. Here's some of the specs here. And what size breakers do I need? I get it all the time. I agree. Maybe not all homes are currently electrified for the equipment that we're going to see, like electric boilers. It's going to change, right? See the means, or for partial usage. Again, well, they can only have a breaker of X. You're telling them I need a 60 and a 30 in a panel to give me 51,000 BTUs. Right. Well, maybe I can only give you 38,000 BTUs. So maybe that's only the 60 amp breaker. So there are means to kind of massage based off of maybe what the house currently has, or new construction, seeing bigger house panels, 400 amps, my house, I can see easily going from 100 to 200 amp service because of, on one direction, all the lighting got reduced, right? We went from flood lamps to, now to LEDs, so you're kind of reducing with technology, and now we're almost challenging on another side to change the offering up for comfort. So I just did the math on the left, at 10, 15, 20 kW. What is just straight, if I had a straight boiler, right? I can add to this air to water and have already on board the backup, for when it does drop below a certain temperature, to make sure that the house doesn't, get compromised. So 10 kW is an additional 34,120 BTUs. Go up to 20, double it, 68,240. What does the envelope require, right? Heat loss. What is our heat loss or heat gain for summer? That's really what we need to start on every going forward project. System M. If anyone deals with Wales Darby, we were a TACO rep 50 years. This is a 100-year-old company. TACO's been around for 102 now, 102 years, close to, I think it's 1921 to 2021, 2022, yeah. So think about a game changer. They now offer something called System M, completely packaged air to water plus domestic. How is a company who has always been around the source now, think about that, the chicken bones, right? The chicken bones, what does it say? The future is, survey says, air to water. And they got into the market. This is a 5-year R&D. They partnered with a large company over in Europe. It's an Irish company, German engineered, Glenn Dimplex, right? It's not a guy's name. Glenn, is Irish, and Dimplex is the German, I believe. And they have been leaders with electric appliances, I think also as old as Electro from like 1974. So the partnership is, we have this packaged outdoor and we have a packaged indoor. So we call the Hydro Box. That is completely manufactured and assembled here in the United States, Cranston, Rhode Island, in TACO's warehouse. I'm sorry, manufacturing plant, right? That little lower block there, 6 arrows, that's all the connections other than electric. That's for domestic, that's for your system, heating, cooling, and that's for your connection to the outdoor unit. Again, like most things refrigerant-based, electrified, there are limitations. What they do allow is 6 kW immersion electrodes to give you a boost. We do have an onboard buffer tank inside the indoor hydro box. All your pumping is in there. To be honest, these things are small apartment-sized refrigerators. One outdoor, one indoor. But the complete package approach now to do also with a optional 85-gallon indirect, storage indirect for your domestic. That also has the boost. It has an electric element in there as well, right? because when we can't do what we need refrigerant-wise, I have the boost for the house with the 6 kW. We said 1 kW is 3,412 BTUs. So that's upwards of 24,000-ish something BTUs in addition to whatever I can get out of a minus, what does this go to? Minus 20 something? 21? Something like that. So refrigerant-wise, we have major capacities to develop, good heat energy or for the extremes of cold. Again, envelope over equipment. I cannot say that enough. Due diligence with what does a space require. All right. Here's just a power. This is just a piping schematic. And this is, as you see back here, it is a handout, right? So this is one of the takeaways for you. And there's Taco's, tacocomfort.com, their website. You want to learn more? You want to get involved? They have webinars, Taco After Dark. They have trainings at their factory. On here today, how many guys have ever been to a factory, regardless of Taco or Space Pack, and ever been to a foundry? I mean, get, in the, get knee deep into what exactly do we do in our industry, right? And go see and touch to see these things being made. I see many people walking Taco's, manufacturing floor and seeing a 007 being manufactured. They look at it as a very simple device, but then they see actually what goes into making it. It's like, wow, there's a reason why there's a cost to things, manpower, labor, so forth. So imagine the outdoor unit, and there's your piping. They prefer below ground, sealed, weather tight. You can go through wall. Some of the things that I'm seeing in coming over from maybe one manufacturer's perspective to now what we do locally, it's a preference, right? Is there an advantage? What do we do? So you can see our outdoor unit is where the refrigerant is. We then bring our water piping. Glycol might be necessary, right? Because we have some outdoor exposure in the extremes of cold. Then we have our indoor hydro box where all things now are already pre-plumbed, wired, controlled. We bring it power, and yes, we have 6 connections if you choose to do the domestic. Otherwise, you have 4. You have 2 for supply return to outdoor unit, and you have 2 for supply return to the home, the space, the system itself. This slide actually shows you how we can incorporate an existing, or maybe I just need to have an additional boiler, okay? So we have flexibility. We have, some means in which I would say you're only limited by your creativity with checks and balance, of course. Don't go so rogue that now you are the warranty. Some interface, some app approach, easy setup. On the right, I'm going to explode that up a little bit here, but look at COPs here. Get deep into what the notes are. See, it says heat capacity, COP. Notice it says 2, 3, and 4. That's not an area code. Those are notes. We need to see what exactly, hey, are they sticking me in a box of limitations? They're giving me some numbers, and it sounds impressive to be, upwards of 400% efficient, but under what conditions? And that's what these notes are here. In your handouts, you will have all of this, okay? The chart to the right is showing your min and your maximum. The dotted line is that 6 kW boost, because sometimes I just might need more. So that's what those charts are graphed there to show you with outdoor temperatures and delivery of BTUs, right? What can we achieve with the minimum and the high side of that heat pump? Do I need more? Yeah, but only in the extremes for a short window of time, right? Because I did the math. I did envelope over the equipment again. This is starting to show some really good, what's the word I'm looking for? Potential for a complete home comfort. I can do the heating, I can do the cooling. I can also do domestic. I can see what the new buildings envelopes are looking to develop. Spray foam, right? Building thermoses, almost net zero loss buildings. Utilizing PV again, right? Capturing the solar, the sun, and creating my own power. Electric could be costly, but I'm offsetting my monthly usage to the utility, and I'm never taking advantage of everything I'm producing on the roof. I'm not storing it, right? We hear also, if you're involved with PV, is having batteries, storing my own electric instead of just offsetting my electric, right? So there's going to be a whole shift in what we see in the near now future. All right, so I've been talking for I don't know how long now, too long. I know Rick is sitting next to me and kind of surveying and seeing your chat. If there's been any questions or if you have anything, raise your hand. We're here. We want to help. We want to engage, and we want to see maybe, in the near now future, what we can do to make you comfortable with even newer technologies. Going back to fossil fuel, like, yeah, how do we do this again? Like, yeah, I'm doing I'm just doing boilers, and how do I make it better? All right, yeah, I do the closely spaced tees. I'm doing the better venting. I got the magnet. I'm tapping into something, talking about lowering water temperatures, because if you do it currently with what you're already established with, but now going forward, you might be a non-believer before you become a believer, simply because I'm telling you, you need to be in that 120 to 130 degree system design temperature for water. And you're gonna go, no way, never gonna happen. So, any questions? Anything we can do as we are coming to a close here?
Looking good, Joe said thank you.
I have something on the wall here. I'm gonna reach over, hopefully you can see it in the screen. So this is just something I had for a year. I put it in the, can you see that? This is something it's just funny because the guy on the screen has a question mark, and it says here, engineer comfort and not guessing comfort, right? So guessing is where I take a 30-year-old boiler that's been sitting in someone's basement, and I simply look at the boiler rate plate and I give them like for like, And engineering might spook people. Like, oh, I'm not an engineer. I can't do math. It's not that hard. Get involved with a heat loss program. Something to give you a quick little cookie cut approach to a square footage. What's the volume, elevation, how many windows? It can be a very simple process. You just need to start and get a little bit more comfortable with it. How many guys are doing heat loss on every job?
Question. Russ was asking, do you see all this happening without government mandates?
Well,
It's already happening.
I say I hear more and more, and it's in pockets. I hear about International Code Council. I hear about municipalities, where I live, like, further out in Hamptons, HERS raters. Again, you have to justify your selection of equipment and prove it. There are rebates that utilities has millions and millions of dollars to redistribute, because again, that money is hours that we gave to them in some kind of surcharge every month. Don't think of it as like, oh, they're giving us free money. No. We're just taking money, we're taking advantage of monies that they are taking from us every month. You as a contractor, as an installer, man, if you're not being questioned about rebates or offering, having that knowledge to talk to the end user, upselling to a high efficiency with an offset rebate to your end user, saving them energy dollars every month. It's a new day here, right? All of a sudden, there's a different verbiage, I didn't want to leave out something, and I wasn't sure if I was going to put it in, but these next slides here, heat pump part 2, right? Air to air. This has been in the overall business of heat pumps, regardless of air to water or air sourced. This is an mid to high 80% of the market in the last decade, products like a Fujitsu, air source heat pumps, refrigerant-based inverter DC components has grown 50, 40, 30, over year after year after year. The growth in which this type of technology is, it's not stopping. It's not going to stop, right? So if you've never seen what they can do here, COP, right? We talked about one COP. There's an electric resistant baseboard, let's say. Let's call it a heater, generalization. Electric is 100% because there is no byproduct, no flue products leaving the building. Energy in, energy out. That's AC, right? The little block to the right, that's an inverter DC now. And that same 1 kilowatt is not 100%, it's now 300%. And this is where and why this technology is going, both heating and cooling, high efficiency. It comes with rules. It comes with, let's say regulations, because the installation practice, this is not a typical, let's call it air conditioner or heat pump maybe, okay? We do plenty of classes on this. It keeps me busy, I promise you. We can do whole house, individual, right? We have single to multi-zones, different looks, right? High on the wall, down low, make it disappear, put it in the ceiling. Again, no horse blinders. You need to start, I don't know, identifying I'm uncomfortable. And then reasons, how do I get comfortable, right? Start working towards that side of the equation. You're gonna be uncomfortable before you get comfortable again. Technology will roll you over and spit you out. So that comes to my end, my closing here. Again, if you didn't get the QR codes earlier, they're now listed here again. I'm on the left this time and Rick is on the right. I want to thank you for your time. I hope there was some engagement for us to kind of maybe follow up. And I hope the topic was something worthy of your early start today. And I thank you for joining us today. Again, my name is Anthony Tosi, Wales Darby. I'm on the New York side of the business, where you see up there we have Philadelphia. It's more of an office. We do have some representation there, but our main two buildings are in Warren, New Jersey, and also Islandia in New York. And that's the parking lot on the left where we had our event just last Wednesday. We had a nice big old tent for people to sit under. A beautiful day last Wednesday. We had 42 attendees. I think we had 7 tents. We had 5 manufacturers. Some had their training trailers and training vehicles, and we had representation from a CEO down to national sales, and it was quite the day, I have to say. So really good. Kudos to my man to the right. We worked hard, a lot of heavy lifting and organizing and getting that thing to fruition. And I think the rewards were great. So
we'll do it again.
Yeah, we will do it again. If you're local, then I'd love to say, come join us. Might be a ride, but it'll be a day worthy to your expansion of, hey, what do we do with the new look of a modern heating or cooling? Have a great day. Thank you, guys. Be well.
Take care.